Welcome to this video. I'm going to show you in an easy and intuitive way how to understand vectors with a little bit of programming, but there's no programming knowledge required. So let's begin. If we were to move the circle to the right, how would we do that mathematically? Or how would the programmer do that? He would say x plus equals 2, which is the same as x equals x plus 2. Now the circle moves 2 units to the right. If we wanted to do that again, we would do the same thing. X plus equals 2. And now let's say that we always wanted to move 2 units to the right. We would need something called velocity. Velocity is the change in position over time. And the velocity of this circle is 2 because we want the circle to move 2 units to the right. Now if we want the circle to move down by say 3 units, we can set the velocity to 3 and increase y by that velocity. I should mention that the origin of the coordinate system in this case is at the top left. But now we want our circle to move diagonally. And since we want the circle to move down a little more than to the right, we now need 2 velocities. One velocity for the x-axis and one for the y-axis. Then we can change our circle's x by the x velocity and y by the y velocity. But now let's see what happens if there's wind coming from the right direction. Our circle should slow down. At the beginning, when the wind is not so strong, we can still move 2 units to the right. But the farther the circle gets, the stronger the wind gets, and the circle gets slower and slower. If we want to simulate such behavior, we must decrease the speed by more after each step. This causes our circle to move first by 2 units, then by 1, then by 0, and finally backwards. This change in velocity is called acceleration. Acceleration is the change in velocity over time. We can now initialize a variable called acceleration and give it a value of 0. Then we can expand our formula by adding acceleration. After each step, we decrease the acceleration by 1 so that the circle slows down after each step. We repeat this 5 times. Our circle now moves to the right, slows down and comes back. Now suppose the wind comes from the left and pushes the circle to the right. And since objects in the real world move not only horizontally but also vertically, we need an additional force, gravity. Theoretically, we could do the same thing for the y-axis that we did for the x-axis. But as you can see, that could get messy. Instead, we create a list of 2 elements called position. It'll contain the x and y value of our circle. Then we create a list with the velocity of our circle, which we initially specify as 0. And finally, we need the acceleration, which is also 0. At each step, the position is updated by the velocity, because the velocity is the change in position over time. Velocity is updated by acceleration, because acceleration is the change in velocity over time. But what is acceleration? Acceleration can be anything we want it to be. Remember our wind power pushing our circle to the right? We can make a list that we call wind that tells us how strong the wind force is. It pushes the circle 2 to the right, but not up or down. So the first element of the list is 2 and the second one is 0. And then there was gravity, which pulls the circle down. Same thing here, we make a list, but this time with the values 0 and -1. Acceleration is made up of these forces. More accurately, it's the sum of these forces. Our circle would now move like this. To be fair though, the circle would move much faster with these numbers, so if you want to write something like this in code, you should use smaller numbers instead. Now if you understand the concepts that I showed you about the motion of an object, velocity and acceleration, you already know what a vector is, since we've already been using vectors. For example, position is a vector. It tells you how far the circle is from the origin. Velocity is a vector, because it tells the circle how far it has to move in a certain direction. Wind and gravity are also vectors, because they push the circle in a certain direction. And finally, acceleration, which is the sum of the wind and gravity vectors, is also a vector. These arrows show in which direction an object should move. And if we add these vectors, we get a vector that can be represented as one arrow. We can always add forces. The arrow then changes depending on the value of the new force. For example, this very strong magnetic force causes our acceleration, and therefore our arrow, to change direction completely. If we add another force, the acceleration at that point changes again. We can draw all forces that are being applied to a certain point, sum them up and represent them as an arrow. What this means is that if there was an object coming from the top with a velocity of, let's say, 4 minus 10, the velocity would change at the point 3, 4. The velocity would be updated with the acceleration, and the direction of the object would change, because the velocity would change. Just for fun, let's say that at the point 4, 6, the acceleration is 1, 3. That means that if the object crosses that point, its velocity would change again. From that point on, the object will move more to the right. Giving each point an acceleration is the basic idea of vector fields. The path that an object has when it crosses those vector fields gets adjusted at each point. Thank you for watching. I hope you've learned something new today, and see you next time. Bye.